Welcome to In 5 Minutes. The agenda of this clip is to understand a DRAM array, how exactly the read happens after delta V is being found as 100 millivolts, or how does a sense amplifier operate so that the read operation is complete, and from there on understanding how through read a refresh mechanism is achieved. Let's quickly get started, and here I'll also compare with SRAM so that you understand which circuits are similar or which circuits are same. Similar means they will be able to give you the same functionality with just the change in the PMOS or NMOS. Don't get confused, stay tuned, it's going to be a wonderful understanding. Let's get started. First is the pre-charge circuit. Here on your screen, if you see, I have drawn the pre-charge circuit for an SRAM which we have already discussed, where there are two PMOSes connected back to back, and here was a phi signal. So when phi was equal to 0, both my PMOSes would turn on and my bit and bit bar line both would go to VDD. This is what we have seen in case of SRAM. This was my pre-charge circuit. In case of my DRAM, my pre-charge circuit is even simpler because there is only one cell or only one bit line. There is nothing like a bit bar line. So it's going to be an NMOS transistor with an input which is nothing but phi, which is nothing but a pre-charge signal, and it won't be VDD, but it will be VDD by 2. The reason being, for the read operation, I want my bit line to be VDD by 2. And also, why did we use an NMOS and not a PMOS? Because NMOS can easily pass VDD by 2. PMOS can also pass, but PMOSs are anyway slower. So here we will go ahead and use an NMOS because my functionality, what I want, is not a complete value logic 1. I need a VDD by 2, so NMOS can achieve that, and NMOS are faster. So my pre-charge will comprise of an NMOS transistor with an input of phi or a pre-charge. When this is 1, this is going to be my bit line. Bit line would be VDD by 2. This is what I want for my read operation. So the pre-charge for DRAM is very simple. Let's quickly go ahead and make it. It's going to be an NMOS transistor with an input pre-charge of phi. This is going to be VDD by 2, also called a pre-charge voltage, and this is going to be my bit line. So with that, I got the pre-charge circuit for my DRAM. Let's quickly go ahead. Now, this is nothing but my one transistor SRAM cell, where this was nothing but my XS transistor, back-to-back inverters, inputs shorted, connected to word line, bit and bit bar line. For DRAM, we have already seen that it's nothing but my word line, my bit line, also called as data line, capacitor, this was node X, this was C cell, and now we can show, or we know that internally there is a capacitor C bit also which is present. The same thing can also be shown when we connect in the array in a similar pattern which I am showing right now. So bit line, NMOS XS transistor, capacitor, I am just putting it this way, so this is my C cell and this is nothing but ground. So this also is a way of representing a one transistor DRAM. Let's quickly go ahead and put it also in our block because this will help us in drawing the entire array. Bit line, XS transistor, C cell capacitance, and this is nothing but ground. You can have different value there also, but then currently I am putting it as ground. And this is my word line. Now comes an interesting sense amplifier circuit for SRAM first. Let's quickly go ahead and do that.